imaginary numbers. So remember when we were doing the quadratic formula worksheet and you get a negative underneath the square root, we'd say what? 2 complex roots, right? We can't solve for those roots. So those roots are imaginary. So we're going to talk a little bit about imaginary numbers today. Stray, I need you to stop shifting. See everybody up here. Okay, perfect. All right, so let's talk imaginary numbers. So we did a little bit of this yesterday, and we talked about how we can't have negative areas. So in order to talk about this, we'd have to talk about it in terms of, I think I'm going to change this because somebody in the last class got it better this way. All right, so does everybody agree that if I were to split up the -1 and the 16, I could split it up this way? A negative. 1 is always squared, right? 1 squared is always 1. And then I've got a 4 squared. So if this is the area of the square, what's the root of the area? It would be the square root, right? The square root of 4 squared, which is just 4. This one would be square root of -1 squared, square root of -1 squared, which would just be 1. But 1 times 1 is not -1. So you can't use -1. You have to use something more special because the rules of negative times a negative is a positive are going to screw us up here when we're talking about this. So we don't want to use this anymore. We don't want to use a -1. We call it I. Okay, for imaginary. Because isn't it imaginary to think that -1 times -1 is -1? Isn't that imaginary? Right? It doesn't work out. So instead of using the -1, we start calling it I. So if I were to try and find the area of this, I would say the square root of -1 squared times the square root of -1 squared. But I'm going to change that, and I'm going to make it an I squared. Which is just I. So anytime you see a negative sign inside of a square root, you can just take out an I. This is this algebraically. Square. So every time you see a -1 underneath a square root sign, with a square or not, it doesn't really matter, it means I squared. Okay, it's that imaginary times the imaginary, which makes an I squared. And the square root of I squared is just I. So we're going to apply that right now. Okay, makes sense? Does everybody understand why we can't use the -1? Because a -1 times a -1 is +1, and then we lose the negative. So we use something special called I. So I'm going to work it in reverse for you, and then I'm going to have, oh, we got to do this first. Okay, so you guys are going to totally laugh at me. But Garfield, I found this online, and I thought it was super, super cute. Okay, so Garfield, what Garfield stands for is that he will eat your lasagna, right? What do you think this is? What's the opposite of eating your lasagna? Making you lasagna. Somebody said giving you lasagna, right? You ready for my nerdy one right here? You're scared? Okay. So when I have this square root of something, isn't that finding the side of the square? Right? If this is the area, the square root would be finding the square. So the area is actually the lasagna. This is the opposite of the area, which would be making the lasagna, right? Eating the lasagna. So this one is, wait for it, we'll eat or make a 2D cross section, which when multiplied with itself is a lasagna. Let me explain. isn't this 2D, two-dimensional? And if I take a cross-section means taking a slice of something. So if I take a slice of it, a cross-section of it, I would just take a slice of it, right? When multiplied by itself is the lasagna. Do you hear? Okay. So if I take a cross-section, it's like taking a slice of something. If I take a slice of this square, aren't I only going to get the line, the side of the square? And if you multiply the side of the square times the side of the square, you get the square. Not that it really matters, because we're talking about Garfield, right? Then this one is, we'll eat or make a 2D cross-section, which when multiplied with itself is the opposite of the lasagna. Anyway, kind of cute, right? All right, let's work with this. Okay, so if I see this, I see I squared. A -1 in there means I squared. So I'm going to say that -1, I'm going to work it all out. -1 times 25, which equals I squared. There's a square in there. It's 5 squared. I take out anything with a square, and the square falls off, and I get 5i. The 5 always comes first. Because they both have squares. Not all of them would be like that. Florence, yeah. Is it -5? No. You don't magically drop anything. This right here tells me that there was a negative under there. We're using the I because it's just a representation that it's a complex root. You're going to see why when we do it in reverse. By the end of this, which is tomorrow, I'm going to give you a root. Oops. I'm going to be able to give you a root, like my roots are plus or minus 5i, and you're going to be able to come up with the original equation. So you've got to know how to use I. I times I is I squared, and I squared is -1. Okay? We'll get there. We'll get there. There's a reason why we're using the I. Okay? We don't have to jump that far right now. Baby steps, stairs, right? Baby steps through complex numbers. Okay. So here's another one. I'm going to say 2 times the square root. -1 is I squared. 49 is 7 squared. Get rid of my squares. They come out. I'm left with 2 times I times 7, which is 14i. I'm going to do one more, and then we're going to start doing whiteboards. This one is I squared times 27 is 9 times 3, which is 3 squared times 3. Get rid of my squares. And I'm left with 3i square root 3. Do that one on a whiteboard for me. And you guys are all in an uproar right now. You're like, you want to know so badly. Okay, so I have a -3. Let me figure out, Lucas, you said, can we do it in our head? And I said, sure, but then you were confused on the process. So until we stop having confusion, let's not skip steps. So a negative is I squared. 9 is 3 squared. Isn't that a proper representation of what's in there? This comes out, and this comes out, because they're both squares. Then I have -3 times I times 3, which is actually -9i. Okay. Okay, cap that marker. You guys aren't using them, they should be capped. Okay, Philip? The reason is because if I were to make it a negative, if I were to leave it like this, negative I squared times negative 1 squared, if I were to leave it like that, the square root of that is negative 1 and negative 1. But what's negative 1 times negative 1, Philip? Positive 1. So if we leave it as negative 1, we have to follow the rules of negatives, which a negative times a negative is a positive. So to bypass that, we decide if we see a negative 1 underneath the square root, we're going to call it I squared because this has different properties. It's substituting it in for something and then saying, I'm going to come back and talk about it later because I know that means I've got a negative underneath that square root. Yes. Anytime you see a negative sign, you put I squared. No matter what. And anytime you see an I squared, you could put a negative sign there. It works both ways. Okay? Does that make sense? We have to substitute in I squared because we can't use the same rules as negatives. Okay? Sydney. Stop drawing. Okay. Moving on. Can you guys do another one for me? Sure. Awesome. You know what I have to do right now? I have to put a call out to Efren for always watching my videos in 5th period. And I think that was about 100%. You guys are doing awesome. So I'm going to go quickly. 2 times the square root. That's kind of messed up. And this is my good copy. 2 times the square root. I hear talking. I squared for the negative. 9 times 5, which is 3 squared, times 5, which is equal to 2. Be consistent here. This comes out and this comes out. So I'm left with 2 times I times 3 square root 5. 6I root 5. Okay, I'm going to blow your mind. Let's go in reverse. If I were to go in reverse and I want to put that I back under the square root, it would just be negative 5. Right? So that's going in reverse. And the 6 would be 2 and the 3, and then the 3 would go back in, but we're not going to worry about that. You wouldn't. You don't put anything. If there's no radical, then it's done. Try that one. Which would be negative, and 9 times itself is an 81, right? So it would be negative 81. You can put it back and forth. I can't get it back to here, really, without making up some other things. Okay. Okay. You guys are doing this last one, right? All right, so I'm going to do this one quickly because you guys are doing awesome. So I have a negative 5 times the square root of I squared. 6 times 4? 6 times 4, 4 is 2 squared. Take out that I and the 2. I comes out, 2 comes out. We're left with negative 5 times I times 2 times the square root of root 6 equals negative 10I root 6. Ready for the fun stuff? Okay. Students will be able to solve quadratic equations involving complex roots. So we're going to do the same thing that we did yesterday. We're going to look at the discriminant. Then we're going to decide whether it's got 1 root, 2 roots, or no roots, and then we're going to further simplify it. And then we're going to look at how we would graph that. But you don't have to graph on your homework, but I figured out a cool way to graph it today. I learned like 2 new things today that I didn't know because I got on Desmos and I started graphing these complex roots. So I'm like, there's got to be a way to graph it, like an intelligent way of graphing it. And then I found a connection, and then me and I showed it to Miss Wiz, and we're like, that's so cool. And then we're like, would it work with something else? And then we tried it, and it did. And then we got really excited. Wait, you'll see. Okay. I'm going to show you. Okay. Talk with your groups and tell me, match each function to the corresponding graph. Can you match it? Let's go by table numbers. Table ACE. Can you tell me which one this one goes to? You can get an idea. The last one. Are they right, class? F18? Yep. Table number 3. Can you guys tell me which one this one goes to? What other one? Why is Philip wrong? Because this is a negative graph and this is not a negative equation. So it has to be this one, right? No, because this is 10, 15, this is 18, and this one's the 50. Okay, what about this one? How about table number 8? Table number 8. Back to you guys. What does this one go to? Are they right? Yep. And this one goes to? This one. You can also see that this one looks a little bit more of like a parent graph, and this one's a little wider, hence the half, right? Because the slope is less or closer to 0. Okay, I don't want to talk too much about this. I'm going to go through these really, really quick. You should be able to see that you could solve these 2. So I could put the x squared on the other side. I need the talking to stop, guys. If I had the x on the other side, how could I solve this? Square rooting. I could take the square root of both sides, and then I've got imaginary numbers. That's why that graph is not touching the x-axis. Okay? This one over here, I could do by adding 1/2 x squared to both sides. Then I can multiply both sides by 2. Then I could take the square root of that. That's using solving by square rooting, right? So we're going to take it a little bit further. I might as well finish them, right? This would be, now this time I don't want to make x squared negative. I'm going to put the 50 on the other side. So we'll leave the x squared here and make it a negative 50. And it still would have imaginary roots, right, Lucas? What'd you say on the weekend? All right. Lots of ways to do this one. I could move the 18 over. I could factor out a 3. No matter what you do, you're always going to get the same thing. So what do we want to do? Okay, let's factor out a 3. So 3 times x squared plus 6. If I divide both sides by 3, I get 0 equals x squared plus 6. Subtract 6 from both sides. You get the idea. Okay. Let's see. Do I want to do it now or later? I'm going to do it later. Okay, so this is last night's problem, but now we're going to go all the way through. Okay, good. First thing we need to do We need to put this in standard form. I need the talking to stop. Okay? Unless we want to start, nope. Caps on pens, just paying attention. Nice. That was a good one. The whole Friends reference with the click and the whiteboard marker. All right, so let's move on with this. So now I've got it in standard form, and I'm going to go ahead and pull some pieces out of it. I don't want to work with those negatives. So I want to just emphasize the fact that this is going to be a negative graph. Correct? So I can pull a negative out of everybody. So I've got negative x squared. If I pull a negative from that, it's going to be positive 6x. Okay, now enough of the clicking, as much as I love it. So now I'm going to identify my A, B, and my C. My A is 1, my B is positive 6, and my C is 11. I kind of shouldn't have gone with the whole blue pen, right? Oh well. So the first thing I'm going to consider is my discriminant. Discriminant. And my discriminant is B squared minus 4. A is green and C is purple. Why am I thinking, yeah, I'm right. The B is supposed to be blue. I did that on purpose. Okay, so I'm going to change over to my blue color, or my black color with the blue. All right, so B squared minus 4 AC. My B is 6, my A is 1, and my C is 11. If I solve for that, I get 36 minus 44, which is 36 to go to 40 would be 4 negatives, and then to 44 would be 4 more negatives, which is negative 8. So I do, in fact, know that I have 2 complex roots. Right, Sarah? Okay, so I have 2 complex roots. Now I'm going to go ahead and finish it. I realize that I am never going to cross the x-axis, but I'm going to have to be somewhere down here because it's negative. Not exactly sure where yet, which is what we're going to look at next. Okay, so if I were to now use the quadratic formula, I would say to find my x's, I need negative boy, couldn't decide to go to a radical party that we already know has negative 8 in it, all over to AM. So my B is 6, and my A is 1. So once you find your discriminant, this part's actually pretty easy. We're just going to talk about my axis of symmetry and how far away it goes away from each other. So check this out. This is with my big ol' ah moment today. X equals. I'm going to go over here on the side and say, you guys never do well when I have it on the same page. I'm going to put it on a different page. What is the answer to this? You should be able to do that in your head. Correct? What if I did this? The answer is still 5? No, it's 8. You can't do that because both numbers are being divided. Right? Does everybody see that? So you have to give it to both of them. So in order to get the 5, I have to say to myself, well, it's only fair if 6 is divided by 2 and 4 is divided by 2. Because that would be 3 plus 2, which is 5. Right? That's the structure in, Kayla, full attention. That's the structure in why we split these 2 up. Not only is negative 6 being divided by 2, but the square root of negative 8 is also being divided by 2. So we need to split it up. They both get divided. So I get negative 6 divided by 2, plus or minus the square root. Negative 8 stands for I squared. What else is in there? A 4 and a 2? So times 2 squared times 2 all over 2. I've got squares in there. That one comes out, and that one comes out. And I'm left with x equals negative 3 plus or minus, what is that? 2I root 2 divided by 2. Now I can cancel right here. Those two can cancel. And we're left with x equals negative 3 plus or minus I square root 2. Here's where my magic happens. This is not what you guys need to do, but what I learned today. Do you guys remember what this represented yesterday when we talked about when there was no I there, it was just the square root? Do you guys remember? They're the roots. So check this out. I'm going to do it again in another capture in another one, and then we're going to talk about it, and then we're going to come back. So we talked about this yesterday, or was it the day before? I can't remember. I'm going to cover this up. What would that mean? What's this part mean? What is it? It represents something. It's your axis of symmetry. Remember that? So I would go over negative 3, maybe it was 2 days ago. I would go over negative 3, and then the plus or minus root 2 is how far over from the axis of symmetry I go, remember? So I would go over almost, a little bit over 1, right, between 1 and 2. And that would be our roots. So I'd go over a little bit, and I'd go over a little bit. Correct? Then how would I find my my vertex? What? I already have my x, and I plug it in, and I get my y. And it's very procedural, right? I would plug in my x, which is negative 3, and I would get my y. I discovered today that there's another way to look at this. You can actually find your vertex by squaring this number. There's a relationship between, so I go over 1, 2, 3. I know that I can't go out I square root of 2 because we don't have any roots on the x-axis because it's imaginary roots. But I could find my vertex by squaring this. If I were to square root 2, what would I get? What's the square root of root 2 times, what's root 2 times root 2? 2. The square and the square cancel each other out, right? Because this would be root 2 squared, which is just 2. So I would go over 3 and either up 2 or down 2. Which one would it be? Why down 2? Because this is negative, means I'm going to have to be pointing down, and it's never going to touch the x-axis. Check this out. So let's do it in reverse. No, we don't want any, right? I'm like right in the middle of like this amazing discovery. All right, let's make up our own problem and see if it works. I made up one earlier. We're just going to do it. Okay. So you guys give me some roots. Something easy that we can find the axis of symmetry. 4. This way or this way? 1, 2, 3, 4. Okay, what else?
3.
Let's do 1, 2, 3. Let's make sure. If I do negative 3, am I going to have something nice? Nope. How about negative 4? That's too easy. Negative 6. There we go. All right, we could build this problem. It's x, and what do we have? 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6? 4 and 6. What's the sign of the 4? Negative. What's the sign of the 6? If I were to FOIL that real quickly, x times x is x squared. 6 times negative 4 is negative 24. And 6x and negative 4x makes positive 2x. Right? That's the quadratic equation for that? Okay. So, if that's indeed true, this is really, if I were to put it in terms of what we've been doing so far, the answer to this is x equals negative 1, because that's my axis of symmetry, and I'm going positive and negative how much? 1, 2, 3, 4, 5? Wouldn't that be the solution? Negative 1 plus and minus 5. Square that for me. 25. So I'm going to tell you my vertex is at negative 1, 25. Because this is positive, it's going to be negative 25 because it's going to look like this. You guys believe me? Okay, take a look at that really quick because I just did a lot. There is a direct correlation between how far out from the axis of symmetry and how far down the axis of symmetry my vertex is going to be. There's a direct correlation, and I discovered it today. So check this out. How would you normally find the vertex? What would I plug in? I plug in my x, right? My x is negative 1. My axis of symmetry is negative 1. So if I put negative 1 plus 6, this is how you'd normally do it. Negative 1 minus 4, isn't that positive 5 times negative 5, which is negative 25. I squared the distance away from the axis of symmetry. I considered the fact that it's going to be a positive graph, which means it must be negative. Right? If it's a graph that looks like this, it's going to have to be negative. All I did was go off of things that I know about the graph. You guys like that? I did what we traditionally do. If we want to find the vertex, we put in our axis of symmetry, and our axis of symmetry is negative 1 to find your vertex, to find the y. It works. Yes. I know. You could do everything graphically. I'm going to show you an easier one. Let's do an easier one. Are you guys interested? It's kind of cool. Well, I don't care about easier. I care about you understanding it. Let's make it easier. Let's do 1, 2, 3, and negative 1. What would be my axis of symmetry if those were my two zeros? Positive 1? Positive 1. So there's going to be a direct correlation, right? So what's going to be the vertex if I'm 2 away? 4. Oh, hold on. What squaring? Okay, hold on. So let's talk about what this means. I'm going to do what it means on this side. I'm going to do what it means on this side, and we're going to do how it's figured out algebraically on this side. What this means that my roots are, if I start at 1, my axis of symmetry, I'm going to go plus and minus in both directions too. So I know, x comma y, I know that my x is 1, therefore my y is going to be 2 squared, which is 4. I know it's going to be negative 4 because my graph is going to look like 1, 2, 3, 4. The graph is going to look like this. Let's do it algebraically. Hold on, hold on. What are my roots? Negative 1 and positive 3? Is this going to be a positive or negative? Negative, and this is going to be a x squared. 1 times negative 3 is negative 3. 1x and negative 3x is negative 2x. So there's your equation right there. Right? And look it has a negative 3. We're almost right there. 1, 2, 3. Which is symmetrical on the other side, which is negative 3. Right? Hold on. I'm not done. If I want to, now traditionally, you guys, you would have counted and found out, or a lot of teachers would do the whole negative b over 2a, find their axis of symmetry. Find your x. I already know what my x is because it's in between. It's my axis of symmetry, so it's 1. If I want to find my y, I have to plug in 1. So I would put the 1. This is how I've taught you before. I would put the 1 in here. And I would get 2, and 1 minus 3 is negative 2, which is negative 4, which is exactly what we have, negative 4. Yes, Philip? Yes. I squared that number. That's it. It's negative because it's a graph that's going like this, right? If it was a graph going like this, it would be positive. Your leading coefficient of your graph is always going to be either positive or negative. This is it's a positive graph. So, you know, it's going, yeah, it depends on the graph or the equation right here. Yeah. It's the opposite. If it's positive, remember the minimum? The minimum and the maximum. They all relate. Okay, Lucas, we're not going there. All right, so can you guys, do you want me to do one more? I'm gonna start by doing it kind of like what I'm doing right now, and you guys are going to finish this. We're going to do what you're going to do in your homework, because you're not graphing your homework. I'm just showing you something cool I found. You guys want to graph in your homework? Okay. Are we ready? So first I need to put it in standard form. So I have 2x squared minus 4x, because I've got to move that 4 over, plus 7 equals 0. Now we're ready to go. My b is negative 4. My a is 2. And my c is 7. My discriminant is b squared minus 4ac. Again, putting my negative 4 in there. My a is 2. And my c is 7. I get 16. 4 times 2 is 8. 8 times 7 is negative 56, which is negative 40. So how many roots do I have? 2 complex roots. From there, I use my quadratic formula, which is negative b plus or minus the square root of my discriminant, which is negative 40, all over 2a. My b is negative 4. My a is 2. Can you guys finish it from there? On whiteboards, please. That's a 4. Yes. Wait. Yes. Thank you. Thank you. Okay, so I'm going to finish this up. So I have a negative times a negative is a positive. So x equals positive 4 over 4. I'm splitting them up. Because this is my axis of symmetry. And this is my how far I'm going over. Right? Okay. So if I do this, I get 4 over 4 plus or minus, let's do the square root of negative 40 is I squared times 4 times 10, which is 2 squared, times 10, all over 4. 2 times 2 is 4, right? Then we're left with 4 over 4 is 1, plus or minus 2I root 10 over 4. Lucas, see where that's the only thing you forgot? It was still over 4. So then this becomes 2. Okay, just want to make sure. They don't cancel. No. They don't cancel. Do you see what I'm saying now? Okay. So x equals 1 plus or minus I root 10 over 2. And just because we can, I think I'm going to, this part is over 2. What does this mean graphically? What does it mean graphically? Well, I know that my graph is positive, because this is positive, right? So I know it's a positive graph. I know my axis of symmetry is where? At 1. I know that I don't have any roots, because this has imaginary roots, right? So then I think of, if I were to square this, what would I get? Well, I squared is negative 1. Root 10 times root 10 is 10. Divided by 2 would be negative 5. So down 1, sorry, it would be because it would be the opposite of it. 1, 2, 3, 4, 5, because we know that it has to go up. No. It's negative 5, but you take the opposite of that because this is y. Or I guess it would be y. Y minus 5, which is y equals positive 5. All right, you guys did good. Remember, you don't have to do the graphing. Can I get your attention, please? Hold on. So you only have to, for your homework, you just have to do 1 through 12. All right? You don't have to do any check. Listen, guys. You don't have to do any checks. I will do the checks with you tomorrow. Okay, have a great day.